And really, it all has to do with something the geologist Aisha Ahmed, near and dear to my heart, at the Tech Resources. She says we have to go from being forensic to predictive. And so much of geology is about being forensic. You take something you already know and try to reverse explain it with some data you've got. And where we want to go as an industry is to become predictive. And we need to collect big, proper data sets early, and then we need to use them effectively. And I think once we show the value of that, then it will become just a necessity to do it that way. So the buy-in you talk about will come naturally through success.
This is a conversation not to miss. Every conversation on this channel so far, I seem to inadvertently end up discussing machine learning. Sometimes intended, sometimes led into it by a guest. It's clearly such a hot topic, and guests have commented on it, questioned it, embraced it, and everything in between. But what is it? What is the difference between machine learning and artificial intelligence? Why is it such a vexed subject? Is it the answer to everything and all? Is it just regression on steroids? Shawn Hood is the Chief Technical Officer at GoldSpot, which is now called EarthLabs, is a company specializing in the application of machine learning to mining and exploration problems. Now, I should state that EarthLabs and RSC do a lot of work together, and that makes me slightly biased in this space, but I do my best to ask the tough questions and get Shawn to lay out how this stuff works and how it is applied. He talks about the history of GoldSpot, the kinds of work that they do for the industry. We cover some of the more specific applications of machine learning in prospectivity modeling. And in the end, no, we don't need to get rid of the geologists just yet. He also explains that artificial intelligence has been around for more than 60 years and that some of it is a bit overhyped. He runs me through some case studies where success has been shown and how to move from fear of the unknown to creativity and innovation. Really enjoyed this talk, finally clearing up some of the confusion about this subject from a subject matter expert. And as usual, if I've left anything on the table, then please let me know in the comments so we may come back to this in a future chat. Let's get into it. Hey Shawn, how's it going, man?
I'm very well, René. How are you doing today?
Yeah, very good. Good to see you, man. It's been a while since we spoke, but yeah, I see you being super busy, and thanks for making the time to chat. I know you're balancing a few things at home at the moment. If partner's on the road, then it's always hard to make everything click. But appreciate you making the time.
Absolutely.
Hey, the reason I wanted to chat to you, well, obviously I should start with a disclaimer. We obviously do a fair bit of work together. So for the audience listening in, a bit of bias on my side because obviously love what you guys do, and I think it's actually a really interesting topic. Well, I've got a few questions that I'm pretty sure people want me to ask of you, because we've been talking so much about things like prospectivity analysis with various guests that have come on, a lot of innovation and research focused chats, and you guys are obviously very innovative in terms of coming up with solutions for problems. And when I say you guys, maybe for people who don't know you, maybe start with a wee bit of an introduction, and both for yourself, how you got into geology perhaps, and why you ended up in tech, if we call it tech. And then maybe sort of what GoldSpot does, a company you work for now, and then we can go from there.
Sure. Thanks, René. I guess, a bit about myself. I at least think of myself as a geologist, an economic geologist. Started in university as an engineer, and it wasn't really a great fit. But at some point, I had to take an elective course and round out some science stuff, and I took this introduction to geology lesson. And it was the very first time in my entire life where I was front and center, in the middle of the classroom, hanging on every word. It was Professor Brian Cousins teaching the course, a volcanologist. And I was hooked, honestly, from like the very first lesson.
Wow.
From there, was very lucky to work in Mongolia near Oyu-Tolgoi, and get a bit of an exposure to the porphyry realm before a few seasons in the Arctic in Canada and Yukon. and then switched to a master's at MDRU here in Vancouver. And at that point, it was pretty clear, like I was finally, I guess, maybe able to bring together the things that I had learned in undergraduate and realize that it was a pretty cool, dynamic, rich field of study, you know, not like the stamp collecting I thought it was when I was growing up, this kind of boring thing of looking at rocks and sort of arranging them in different piles. But there's a lot of interesting scientific work being done in the field. After master's, I went to work in Australia for about 5 years in the gold fields. And it was that point where working in exploration and in the mining environment, I started to realize about the data problem that was happening in, or has continued to happen in the mining sector, between different sensors, assays, historic data, new data, conflicting data, incomplete information. You know, people don't bring things together to make cohesive or holistic stories or understandings of deposits. And there was this other interesting thing, and this came a lot actually from working with Jackie Coombs, who was my mentor when I worked underground. She, you know, was always pointing out to us how a modicum of geology could overcome huge problems with incomplete data, with a reliance on math or statistics. And from there, it started to germinate in my head this idea that, you know, geology was fundamental, and statistical and technical approaches were things that we bring to the world, and we use them to solve problems. But fundamentally, you know, the domain expertise that a geologist has through training and experience, that's the true power of being a geoscientist. So in a big company, you can imagine it's not super easy to innovate. It's difficult to bring new ideas to the table, although we were able to do some pretty cool things there in the resource department. One of them was the work as part of my mentorship with Jackie on prior probability modeling. So prior probability, you know, if you're familiar, this Bayesian statistics idea that rather than trying to impose an understanding of what mathematically is happening in a geological or otherwise statistical situation, you know, you let the data speak for itself. And by looking at the data and what it's telling you, you start to realize that, you know, things are not easy bell curves. Things are skewed. Things are incomplete. There's interesting overlaps of populations and domains. And that led me to investigate machine learning. So I applied for a PhD study at Codes in University of Tasmania. And I was really fortunate to work with, I guess he wouldn't like being called this, but, you know, like a father of machine learning as applied to bedrock mapping and geological lithology understanding and modeling. And that was Dr. Matthew Cracknell and his former supervisor, Anya Redding, who's a geophysicist. So we worked together a lot on the application of machine learning and AI towards solving geoscientific problems, especially in the economic geology and exploration realm. And it just sort of started to open up all these doors. People in the industry clearly were thinking about this problem, but people hadn't gained a foothold in how to solve it. So I was very lucky timing-wise that around the time my PhD was finishing up, GoldSpot Discoveries had emerged from a hackathon a few years earlier, where they took the second place data science prize in the Integra Gold Rush Challenge because they had thought about the problem as a data integration situation. And to accomplish the data integration, they brought machine learning techniques to the table. And this really impressed Integra. It led to a few targets and a few innovations on that side. And the fit was pretty natural that as I left university and came back to industry, that I joined up with this pretty young and dynamic team who was making big waves.
Nice. Yeah, what a story. I mean, that's, you're spot on. I mean, we deal with data so much, and I was talking about this quite recently. It's a talk that's still, or it might be coming out before this, I'm not really quite sure yet, but a lot of people talking about the data problem. I talked about this with Sandra Occhipinti the other day. We said we're actually not that bad with looking at big data sets, but I think it's a very subjective sort of, how people look at big data, and that being whether that's the problem or what the things that we're trying to solve. And I think there's a few things that you said in terms of that trajectory that we've covered on the channel already. I talked to, and I'm sure if you listened to a couple, but I spoke to John Wronski the other day, who's got a very sort of classic strong geology systems, mineral systems driven approach to mineral prospectivity. And we've been wheeling out the machine learning a number of times. Actually, Jackie said the other day on the channel that it was machine learning is regression on steroids, I think was the term she used. And it's so I've got a lot to explore, and really hoping that you can get some of the mystique away from this topic in this talk, because I'm not an expert in this field at all. I did some prospectivity modeling, back in the day, I guess, which is not really back in the day compared to a lot of people who've been around for much longer. But, say 17, 20 years ago, fuzzy logic, weight of evidence, sort of classic approach, and biased. I saw some information the other day being put out, I think it was June Cohen, on the bias of clustering of data, or the drilling density of data, that there's a bit of a problem in terms of how we deal with that as well. So to what degree do these solutions accommodate for that problem? And is it really just buzz? And I'm getting really high level, but is it really just buzz? And what can you point at where this thing clearly works, because that's what we all want to see, right? So this was the problem, and we tried it this way, it didn't work, and now lo and behold, we've got these techniques, and see, here's the outcome. So, and that's probably diving right in the middle of it, because that's, just come out of your, just a bit of an explanation of where you come from in a background. But that's always been fascinating, and this is such a fast-moving part of the industry, where again, even there are people trying to enter into the industry. I was talking to a contact of mine today coming out of the oil and gas industry, and they are looking at what is new and what's happening out there. How can we better apply techniques to our data? So are you convinced that, or convinced, that's probably not the right question, but to what degree is what we are trying to face a data problem and not a people problem, or data, systems, and people? Where does the emphasis lie?
Man, you just gave me so much to unpick.
Sorry about that.
No, that's great. I'll start at the end and go backwards. Okay, so the first thing is data versus people. That is so hitting the nail on the head. In a lot of ways. So in the true definition of artificial intelligence, for example, which people chuck around as the craziest buzzword, it can mean anything under the sun. Right. AI is anything impossible, anything interesting, whatever they joke about. But, it's very well defined. It's not like a mystery, even though it's been
around as well, right?
Oh man, it's been around since the 60s. So the very first, if you go to the historic textbooks on artificial intelligence that were written in the 70s, in the first chapter, you'll see a success case study. And the success case study is a geological discovery, the Mount Tolman deposit in Washington. It was a molybdenite deposit. So it's like constantly shocking to me that, I meet geologists and they're like, this new AI thing. And it's like, dude, it's like since 1979, it's literally in the textbook, and you can go read the textbook. And this is maybe one of the great points to make, is that a lot of the keyboard warriors who sit and maybe cast aspersions, I don't think they're maybe doing a lot of reading. I think there's a lot of straw man style arguments, but the good news about that is that we can unpick them, really quickly and easily. So if you think about the definition of AI, which is really the reproduction, the automation of something that would have otherwise been done by an individual with intelligence, it's not a thinking machine. It's reproduction of a task that would have been done by somebody thinking, then it's all very kind of, it's a bit mundane, which is good. So if we're talking about automation, and it's automation based on X, so machine learning is a subdivision of AI, and it's based on the idea that you can have an algorithm that isn't a simple linear function that has data in and a result out. It's data in, a result, a function that then checks the result and iterates over and over and over again, trying to optimize down to some key point where the cost function balances and it says there's, you can't improve with any more data. So this is the likely function that defines your prediction metric. So that's, maybe getting down a little bit too far into the weeds, but, if we consider that AI and machine learning is statistics, it's automation, and it's mathematical iteration to optimize something, nobody's arguing with that. Nobody would ever say that's good, bad, or otherwise. It's simply a tool that you can use to do something.
Yeah.
The question is, if you create a tool that has value, who would you give that tool to? You can think of many parallels in life. A dentist with a hammer is a scary thing. A dentist uses a nice fine tool and it gives you painkillers. AI is the same way. You wouldn't have AI try to do something that it wasn't designed for. And conversely, the field of artificial intelligence is very, very broad. We're talking about an entire huge discipline that's existed for 60 or 70 years. It has specialized fields within it. You can take undergraduate courses in it, master's, postdoc, PhD, you name it. There's entire companies that specialize in AI, and they look nothing like the company that I work for, which specializes in AI. And that's because it's simply a tool set and an approach, but the utility of it comes in by the user. So I guess the question, like for example, you mentioned John Hronsky and his a traditionalist view on a mineral systems model. This is the foundation for a lot of the machine learning that's done today. The idea that we are going to look for a pattern within data, but that data should relate to the signal we're trying to eke out of the pile of data. And of course, if we consider an ore deposit manifestation as the result of a number of physical processes in the Earth's crust, then we're thinking what data layers have a fraction or a fragment of that signal, and then we're going to layer those together. If you think about a conventional geologist, maybe even when I started, I used to stand at a draftsman's table, a light table, and we would have a layer with gravity data. We would have a layer with the first vertical derivative of magnetics. We would have a layer with the known deposits, and we would put those on the map table, and we would look, and we would basically eyeball, is there a relationship between those layers and a deposit? And then we would look for other regions where that relationship existed. That is not an efficient way to interrogate data. A lot of the machine learning prospectivity work being done is just an automated version of that. So I struggle to see how that's not so comparable to what all of our favorite geologists have done in the past that it should be dismissed. And in fact, we should be celebrating this. We've moved from the draftsman's table to the digital CAD environment. I don't think it means that we have to get rid of geologists.
No, and that's the thing, right? Because nobody's necessarily disagreeing. And what I'm hearing you say, you use the word keyboard warriors, right? But, people who, I don't know what it really means, but I just see indeed a new tool with perhaps a new utility and a new way to look at an old problem. And I think everybody can get to the point where you acknowledge that the human brain can process all these layers of data in a method that is consistent and without bias. So this is where the user interaction is obviously important. You do want to steer it, and maybe you can get into a little bit of detail on how one does that without introducing that bias, and what the process is, or supervised, and what any of that means really. I think people might be interested there. But because, at the end of the day, people like John and others, and I might have singled out John because I just spoken to him, but it got obviously a wealth of experience and actually can point to discoveries where they've been involved with through that diligence process. And but it is getting harder, and as we were talking about on this channel, it is now about tapping into more subtle signatures in places. I talked to Sandra Okapintu about this the other day. What techniques can we apply to peter out more subtle geochemistry sort of nuances and signals in very noisy data, whether it's through regolith or a depth and all those kind of things. And there must be an application in data analytical tools like these things. But thanks for clarifying, a couple of things. Is at least a difference between AI and machine learning that I heard you talk about, which a lot of people get confused about. So that was quite interesting. And then indeed, the level at which it needs to be applied. And I mean, we are a conservative industry, and I keep coming back to this point quite regularly as well. So it must scare people, right? New things, ooh, bad. It's who wants change? Yay, who wants to change? It's a bit of that mixed into that.
It's an interesting point. I actually have seen a very dramatic shift in the last, I would say it's only in the last even 3 years. When I started at GoldSpot, there was a lot of resistance. There was a thought that any data analytics was sort of a black box, that it was something people were trying to replace geologists. And truly, there were a lot of groups who use that narrative, including some very major computational companies who said, we're setting out to reduce bias by eliminating geologists. And very interestingly, all those groups have sort of quietly disappeared. The groups that have succeeded, like RSC and GoldSpot, are the ones that have, with quite a lot of openness, maybe some would say being overly open about the limitations of the technology, have managed to earn the trust of the users or the people who are applying it, so that it can be seen as just another weapon in the toolbox, I guess, tool in the toolbox. The work, that is going to be needed in the next few years is a continuing education, I think, in jurisdictions outside of North America and Australia, who I tend to see them as the leaders in use of data sciences. You said that there's a bit of a fear and conservatism in the industry. I saw that 3 years ago, but there's been a bit of a regime change. And on average, the decision makers in companies tend to be a lot younger, and they're becoming younger all the time, or maybe I'm becoming older all the time. But there is an expectation that we can use data science and AI and machine learning. So the conversation has completely changed. It's not prove to me that this technology can work. That's not even a discussion. It's which one of the tools are you going to use, because I'm already convinced that it works. I already use it on my phone. It recommends me my favorite music every day. It shows me recipes I want to cook. So how are you going to help me find, or which algorithm will you use? I find that really exciting, because now we're moving from fear into creativity and innovation.
Yeah, that's so well said. And as you know, we feel the same vibe coming along. As you see from some corners, you'll find that suspicion, I guess, a little bit, but it's certainly changing very fast. And what a great time for you and the company to get into this, right? Because you're really paving the pathway there and are leading to sort of. There are other companies who are in this space, but you guys are really making it up as you go along and really leading the front there, which must be exciting, right? Because you're. I talked about, I don't know, I think you're probably familiar with data mosaic that Cyro has come up with, and it's a very simple example of something you can do with data. And I guess those sort of algorithms to very quickly see a whole bunch of downhole geochemistry data and other downhole logging tools, and then ultimately an algorithm of some sort, because your eyes can see probably by just looking at some strip logs, okay, there's something going on there. But for an algorithm to very cleverly compartmentalize that for you and to throw it into blocks, suddenly the light goes on and you see something, you go, aha. So, there must be, what sort of, and I'm sort of diving left and right a little bit here, but what's your general strategy with GoldSpot if somebody comes up with an idea? There's obviously an R&D department that you guys have. How do you split up the client service requests that come in and the R&D, and to what degree are you Are you aggressive with developing new ideas, and are you allowing that to just run its course and invite people? You've mentioned the word hackathon, so you're obviously in the space of creativity and bringing people on board from outside the industry. Do you throw them in a room, lock the key, put a lot of coffee on the table and said, do what you like? What's the creative process there?
Yeah, what I heard recently that you can solve any problem by locking people in a room and buying them pizza. So yeah, it's an interesting thing because it definitely it's situational. I think there's a difference between developing commercial software, as we know and love, to solve day-to-day problems in the mining industry, and then it's a totally different thing to solve creative problems, innovative solutions, to make those from scratch. At GoldSpot, it's quite a variety. So we're very lucky to have a group of people who are incredibly creative. One of the reasons why we like working with RSC as well, because it's a very similar culture. There's the idea that you see problems in the exploration space, and you sort of work backwards from that. What's a way that we could solve that? What sort of data are available? What's affordable for people to collect? How can we massage it one way or the other? There's a lot of that, and indeed the structure of GoldSpot has been created so that the R&D and I guess applied consulting groups are very complementary. Mm-hmm. So whether we're working in a regional exploration setting or a near mine setting, there's always, I don't think we've almost done a single project where there's not some list of R&D pipeline that's emerging from that. And then we track that in sort of what we would call the agile development framework, which in the computer world is just like a triage system to prioritize good ideas and to break them down into achievable units. When I started, it was easier in a sense because it was a lot of geologists who had self-trained to program. And so we would sit down and laboriously, try to write up our ideas and capture them in code. But it's a totally different situation now because as the company has grown from 10 people when I started to 100 or so now, the caliber of computer scientist, computer engineer, software engineer that's entered the company, it's not even the same ball game. And it's incredibly rewarding for someone like myself who struggles to write blocks of code and capture my ideas digitally. I mean, these are things that by sitting down with somebody who's trained in the space, explaining and building a relationship with them with a common language between geoscience and data science, I mean, you can do incredible things. And their understanding of how to write code efficiently, to optimize problems, and also bring solutions from other spaces like medicine, self-driving vehicles, analysis of the stock market. Like these are what the students are learning at school, and then they're bringing this into the geoscience world. So on a larger level, what I'm starting to see is an integration of knowledge outside of geoscience or from outside of geoscience into geoscience, which we have seen in the past in academic literature. People take ideas from the world of physics or chemistry, and then they port them across to geology. And it's very slow because that idea is published. Somebody else needs to read it. They need to think about how it applies to their problem space. And then they have to create a version of that for geology. GoldSpot, by being partnered with universities, research institutions, hiring interns, sponsoring students, sponsoring degrees, I mean, we're basically fast tracking all of that so that we're explaining geology to people who have no idea what a drill rig is. They don't know what an outcrop is. Mm-hmm. We need to tell them what dip and azimuth are. But at the end of a 6-month stint, I mean, they're pretty switched on. And not only that, they're starting to run past what we're thinking about into whole other realms. So it's a very rewarding experience. I would almost say that in some ways it's more like a research institution some days than a consultancy. But the benefit is from all that rich innovation comes tools and products which then complement the applied world of exploration and geology.
Yeah, look, and there's so much in that I completely agree with. I mean, and I can't remember who I was discussing this with, but the flexibility with the size of where, you know, both IRC and GoldSpot are, you know, the creativity that you can actually really do something with, you know, how can we, you come up with a problem gets presented and you actually have the ability to come up with a solution, and I like the word that Jack uses in this space as well, because obviously as a mutual acquaintance, their curiosity, right? You wanna bring people in the group who have that natural curiosity, and geologists are pretty curious, you know, creatures. So, you know, throw some program, and you know, it's interesting that because so many young geologists coming out of university, yeah, they know Python. Of course I know Python, you know. I mean, doesn't everybody know that? And I remember that I, you know, fumbled around with Visual Basics and Basic, and actually Basic before that, and I have no idea. I lost complete touch with the programming world and what you can and can't do with it. But you know, throw all of that together. That's really the appeal to me as well. It's that overall problem solving that is, you know, as I joked the other day, it's getting paid to solve puzzles, and that's pretty that's a nice place to be, and then coming up with new ways to do it as well. So I really appreciate diving into that. Maybe take a sidestep in a couple. So maybe come up with a few examples. So we talked about prospectivity, and there's obviously a whole approach and a whole workflow that is now. You know, that's your IP, right? And you really are having success with that. And I wouldn't mind if you have a couple of examples for listeners. But you also have some logging products. So maybe, you know, give us an example of a couple of the tools that you have where this has really worked for GoldSpot and why it's popular.
Yeah, sure. So, you know, and also I'm going to say this very freely, that the idea of the prospectivity analysis, it's an old idea. You know, you yourself just said about using weights of evidence and fuzzy logic. Those were especially hot around, you know, 2001 up to 2001, and a lot of that was pioneered by the Geological Survey of Canada as far back as 1982. There were the first weights of evidence papers coming out. So I don't want to say that you know, GoldSpot invented that. We really did stand on the shoulders of giants, and where the innovation has come is not in the selection of you know, a better algorithm than others. What it actually comes from is better processing of the source layers that are going into these projects, such that they're pre-processed in ways that augments the various signals, whether we're talking geochemistry or geophysics or structural geology. You know, one example might be, you know, it's more valuable in some cases to use the first vertical derivative versus the total magnetics. Maybe an example would be it's more valuable to use stress modeling, low stress versus high stress kinematics in a region versus, you know, just foliation measurements. So those are the types of things that are done to improve the quality of a machine learning output. So when it comes to sort of other forms of machine learning, as you know, you were alluding to core logging and things like this, this is, I think, where the future lies. So prospectivity analysis is the holy grail that people have been looking for 40 years. And people like John Carranza have published beautiful papers as far back as 2007-8 on this subject. They are the seminal things, and I would encourage anybody interested in the subject to look up, you know, John Carranza's GIS and prospectivity.
We'll put a link in. Yeah.
Absolutely. I would. Yeah, I'll put some in the show notes. So that has led, for example, at GoldSpot, led to successes at GoldSpot. For example, the newfound gold discovery in Newfoundland, which was a beautiful combination of field geology and data analytics combined together. One of the very recent ones was for Quebec Precious Metals, and we actually had 2 discovery successes there. Pretium Resources in British Columbia, which was acquired by Newcrest shortly afterwards. Lithium discovery by Critical Elements in Quebec. So, you know, it's getting to the point where if I'm not seeing something that we can press release fairly regularly, I get a bit grumpy, and the team and I get together.
Yeah.
it's always difficult in the major companies to talk about successes, but with the smaller companies, they're very proud to point those out. So that's really cool. If we think about AI as automation, though, that's much more than prospectivity. Prospectivity is the idea of looking for a deposit in a data stack, but automation and pattern recognition can be many different things. So one of the aspects, let's say something that challenges geologists a lot, and I have done a lot of core logging in my life, as I know you have, is making consistent observations from drill core. And that might be usually a kind of a subjective analysis of something. Is it super red, a little bit red, brown red?
You're being kind here, I think, but yeah. That's
Is the foliation strong? Is it intense? Is it weak? And
exactly.
I love talking to Julian Verncombe about this because he uses a lot of swear words when he describes core logging. You should interview him, by the way.
Yeah. No, he's on the list.
Yeah. Okay. So when I started at GoldSpot and we started looking at basically machine vision, it was a natural thought of two cases where machine vision is important. One is looking at satellite imagery and looking for patterns in satellite imagery, and one is looking at core imagery. So we really began with the obvious things that a person would look at when they looked at drill core. What's the color? What's the texture? Is it broken? Is it intact? And then coming up with metrics to measure that. And very quickly, the deep learning people, coming back to my point about outsiders seeing geology with different eyes, they said, well, that's interesting. You're looking at this kind of measure. And what you're really looking is the jaggedness versus the total area of a fragment. And, there's different ways we can look at that. Why don't you measure it this way? Or here's a branch of deep learning that generates metrics for you and then tries to explain them. And you start to look at what these algorithms are doing and you think, oh my gosh, I never thought about that. Oh, it's trying to account for a 3D aspect. And I only look at it as a 2D aspect. Really interesting stuff. Fitting curves to the drill core in a flat image to understand alpha angles, record those, and to plot the densities so that we can look at areas that may be dangerous for mining, and then giving that information to mining engineers. Where it gets really interesting and exciting is the integration with other data sets. So by now, everyone's familiar with the different core scanning technology, whether it's hyperspectral or whether it's chemical. And there's many providers out there producing great high quality data. But the integration of the visual data with the chemical data or the hyperspectral mineralogical data suddenly gives us a predictive power or even just an understanding that we never had before. You can't look at a rock and know for sure if this white mineral is what species of mica. You don't know. You don't know where it sits in the pelagic glaze solid solution. But now we can. And so there's some fundamental changes happening in this space where rather than bringing the core to the core yard, producing a admittedly junky log, then analyzing it, then revising your log, which I used to do constantly in the mining situation, constantly revising my own logs. Now we can scan it, we can produce a pretty good log, but then we can revise it as a geologist. We're kind of flipping it on its head. The result, which is important for the resource geologist, is better ore body knowledge, better resource domains. This has huge implications because
it's a game changer.
It's a game changer.
It's. I mean, and you and I talked briefly when I put a paper out on that 2019. All the way to resource geology. If you hinge everything on a bunch of blobs that come from your gold grades, then you're not tapping into enough data, and that's sort of one end member of a spectrum, obviously. But it's still difficult to. I found, because obviously as a service provider, I mean, we don't sell core scanning facilities. We work with groups that we know provide the service, and I mean, we do obviously have a portable XRF service that ties into this as well, because it gives you it gives you more data layers, and we just know that it works. You have all that information plus these clever ways to look at data. and suddenly your domains firm up and all those error bars around. I mean, we talked a lot in the resource geology industry in the last 2-3 years, a few papers coming out on the confidence in domains, right? The uncertainty around geological domaining. It's a big topic, how to improve it. Obviously, software providers, and I do have a question for you, and I'm sure you know what it is in a minute, but around how software providers are positioning themselves in the space. Implicit modeling is 19 years old. How do we interweave all these solutions? And there is something there, but I find it interesting how difficult it is to sell core scanning, not services, but work to clients or solutions to clients. And more often than not, because they're a small company, and it is still an extra investment to make, right? I mean, at the end of the day, budgets are limited. How much extra information is truly going to come from this core to give me, you know, the final answer? And it's really hard for us to quantify that. We can say, well, we know it works, but how do you present that as a solution? I mean, and that's not a question, that's just more of a statement of that's difficult to do. But yes, as we get paid to look at a few hundred deposits over the years, that picture becomes quite clear to me how much of value add it really is. So I find it really interesting, when you say this is the future, I wholeheartedly agree. There is so much more value to add in the information we can extract from drill hole data. So what's the name of the tools that you guys have developed in this space?
We've got a few, some of them just coming online shortly. And I guess the main focus of these tools is what we would call the upstream portion of the mining value chain. So it's really around data collection, organization, and interpretation so that good geologists can interpret the data. So we've got a range all the way from just simple core logging. That would be Geotech. That's actually a company that joined GoldSpot a year or so ago, 20 years in the business, very, very popular in especially Quebec and Canada in the Val d'Or region, really respected group of people, but never really known outside the French-speaking portion of Canada. And we realized right away, oh my gosh, these guys know how they've empirically figured out how to record core logging data so well, and it's just a simple case of bringing their story to the rest of the country, and the uptake has been absolutely huge. One of the things that Geotech has done for years is making sure that the core photos would be what they call linearized, and what they mean is that they had a software that they wrote long ago, so that each core box you would put a little box around, and then you would move all the little boxes and you would stitch together your photo. Okay, super logical. Well, the deep learning people who have been working on the image analysis from a textural and chemical integration perspective said, but we wrote convolutional neural networks to do that ages ago. Why don't you just use that? So there's like this natural pairing where the core logging geologist now can upload the core photos to the cloud. The cloud sorts out the core photos, and now you've got your beautiful stitched together piece of core. And it's those simple little innovations that are helping people to do their work a lot faster and more consistently. Once the data is in that sort of form, and we have the rock logs and the observations and the chemical data, we have our own version of what Data Mosaic uses, signal processing for chemical or categorical data. And it naturally creates effectively a pseudo log to understand, the distribution of the different data layers, grouping them together into natural similarities or dissimilarities, but giving the geologist the ability to decide what the scale of those are. So effectively, It's like the lumping and splitting problem.
Yes.
And then from there, we sort of start to model that in 3D. We have a variety of software to do that, which I'll answer your question shortly. But that's about the point where you've now got your logging data or surface sampling data into 3D. And that's when it starts getting exciting, because now the geophysics data can come in. And we have a geophysics acquisition department. They have a multi-parameter sensor system that they've amalgamated so that they can create the data layers that are most efficient and effective for prospectivity analysis and make those robust and consistent for any client that's using them for regional exploration. So this is where, the two sort of data streams come together, and it's all about modeling things holistically in 3D. And once that's done, then the expert geologists in the fields of
Right.
geochemistry, structural geology, geophysics are coming together, and they're working to understand, what's the mineralization history here? What is the mineral systems model? What can we use to predict where other mineralization will be? And really, it all has to do with something the geologist Aisha Ahmed, near and dear to my heart, at Tech Resources. She says we have to go from being forensic to predictive, and so much of
Nice.
geology is about being forensic. You take something you already know and try to reverse explain it with some data you've got. And where we want to go as an industry is to become predictive, and we need to collect big, proper data sets early, and then we need to use them effectively. And I think once we show the value of that, then it will become just a necessity to do it that way. So the buy-in you talk about will come naturally through success.
That's a really nice way to look at it. It's and before we move on, that if you're a client and you're listening to this, or you're not a client, if you are an explorer and you listened, okay, well, that was 5 minutes of a whole bunch of stuff about, I just want to, buy the plugin for my Leapfrog license so that I can see this. Can you maybe just break down the actual commercial, practical side for people who say, look, that sounds interesting, I'm on board, but any of the last 5 minutes is gobbledygook to me. I just want to understand that if I get this plugin sort of algorithm, then it works within my QGIS or within my Leapfrog. Do you have off-the-shelf products that people can just go and buy on a website, or is it all custom built with a conversation with a client? What should people be looking for?
The answer is a bit of A and a bit of B. So as you can imagine, when you're at the bleeding innovative edge of all this stuff, like there isn't, when we look side to side, there's just nobody there. We're inventing the stuff as we go at what is effectively like breakneck speed. And what it means is that we had to transition through a number of phases. So the first phase of the company was really a lot of traditional geological consulting with the augmentation of using prospectivity analysis. But it was kind of the conventional stuff, like I mentioned, what John Carranza had been publishing for years. The second phase of the company was starting to develop the ability to write machine learning libraries, code bases, and infrastructure so that clients' data was coming in, it was being massaged into the right form, and then it was being used by geologists who knew programming, but they're physically like typing out, code as they go and allowing the results to be made. In the phase 3, which we're in now, this is the really exciting point, because we've now had the proofs of concept and the field tests of all this work, and it's time to wrap it into the platforms. And these are the platforms which will be accessible to the public or to expert users, similar to software such as, for example, Oasis Montage or Leapfrog. I mean, Leapfrog is not something you could use if you're an accountant. You have to still be a geologist to use it. As June Cowan would tell you, you have to be kind of a slightly good geologist to use it well. Otherwise, you're going to make bad results really quickly. And I love that. I've been following June for absolutely, it's almost like a decade now that I've known about his work and followed it, because he has always been one of these people who tries to push aside the junk and say, you got to be a good geologist to use the tool. That really informs what we're building. So in the software parlance, what we're doing is we're building the API connections to software like QGIS. And we are a sponsor of QGIS, a financial sponsor of both QGIS and of the company who's working on the cross-section plugins. So we really try to put our money where our mouth is, and to create the linkages between the software that we see people using in the industry and our own solutions. So what it means for the end user is one of two things. If you don't have the time or the people, coming back to your question about data versus people, most groups are people poor and they need help. GoldSpot will supply the people and the expertise and the computation to work to solve a problem, sometimes over multiple years. When groups are very capable, and there's a number of mining companies that I can't mention by name, they have excellent geologists and they don't need our people. So we simply give them the data links to plug into their software, which is typical off-the-shelf stuff, and effectively they send us the data, which is processed in the cloud. The results come back. It's what is called federated learning. It's totally ISO standard security, not observable by GoldSpot, and off they go to make whatever beautiful things they need to make.
Yeah, no. So, like you said, a bit of A and B, and tailoring is everything. So that makes a lot of sense, and that actually does lead me into this sort of next page, because you mentioned 3D already, and you mentioned June very briefly. Leapfrog. There are software companies out there that are obviously trying to tap into this, and there's going to be a commercial component to that. But admittedly, I did look at a bit of a trial output made by MapTech of a deposit that I sent them, and I had very low expectations, and it came back, and I thought, shit, this is pretty good. It didn't blow me away, but I was completely surprised by the fact that it built what I had spent 6 weeks of building before, and whether explicit or implicitly and all the rest of it. So I was quite surprised, but I'm not sure to what degree. I mean, like you said, they're all algorithms, right? So we don't need to necessarily. Is it just that these companies just put machine learning on it because it sells at the moment, and what's actually happening under the hood is not all that fancy, or is just basic algorithms but cleverer ones? Because I mean, these companies have huge R&D budgets, and to remain relevant, they have to come up with new ways to do things. So I'm not sure if you. And I haven't explored all these softwares myself, and I only looked at that one example, but I am interested in your opinion there, is because I did speak to Mike Stewart about this as well, who works for Sequent and who's good resource geologist with lots of experience. What are there any innovations that you see happening from a domaining perspective? Because I think we all are pretty clear that from a training data perspective, you won't have a database with 1,000 different geometries for a particular ore body style, because the 1,001st deposit will be different than all those other 1,000. So how can this work in resource geology, and are people actually doing interesting things there, or is it all just a bit of a hype?
I think it's changed away from being a hype, which is amazing. So I remember sitting with Michael Gaisley, another RSC geologist, for anybody who doesn't know Michael. But Michael and I were at an AusIMM conference a few years ago, and we watched an automated domaining presentation, and it was painful. It was really bad. And the reason was because the approach being used was so obviously not geologically appropriate. It was painful, and everybody in the audience was groaning, and the poor character on stage who had no idea about geology was really squirming because they could hear these noises from the audience, and they're not sure. And don't my statistical analytics really said it was working well. But what has obviously been the natural consequence of that is that person has gone away and talked to somebody who's a geologist, and then they've improved their system. And I've seen this in no fewer than 4 different companies, all of whom have very, very smart people, but they didn't respect the importance of, as Jackie would say, an ounce of geology. That's all that was needed. And by changing the data that they fed in, they avoided the garbage in, garbage out scenario. And by building in a few conditions, that you shouldn't join geology across a fault, or that, you shouldn't join something more than a certain distance away, some simple variography, some dynamic anisotropy, all those types of things have completely changed the game. So where I think things are going into the near future is that some of these groups appear to be working on very complementary products, and we're going to see a continuation of the merger and acquisition style process. I mean, Sequent picked up, Micromind picked up. Constellation has been picking up a few groups and putting them together. The question, which I have no idea, no answer for, is whether or not the innovator's dilemma starts to rear its head at that point. There's something about being dynamic and nimble that allows you to solve problems creatively and quickly. If we're working in a big company as I have done before, it's very hard to innovate because people are not really tolerant to that, and they're not willing to take risks on things. So if these great ideas are absorbed into big companies, will they die, or maybe they'll flourish? Only time will tell.
Yeah, look, that's a good point, and yeah, the future will tell. But I'm certainly, excited to see what they can come up with in the future. And one of the reasons as well, and this might be a nice topic to sort of close off with, but and I think you and I discussed this a couple of years ago as well. A lot of these new innovations, they do need to find acceptance. Broadly speaking, and one tool that people, I think, not necessarily correctly reference too much are the codes that govern us, right? JORC or CIM, and if it's not endorsed by the JORC police, then it shall not pass. And I heard somebody say the other day in one of the talks that, and I didn't necessarily feel the need to correct him, but the JORC had endorsed the Chrysos photon assaying, and I was like, I don't think the JORC has put a letter out endorsing that. It doesn't work like that. But it did raise an important point. There is that perception of that structure, that there is this overall court with 9 judges that needs to decide whether this new technique is suitable, and this is something I've been fighting, or not fighting, but investigating my whole career. What is this structure? Who is involved with it, and who decides these things? And it was implicit modeling first, because a resource, you couldn't put a resource out that was built by Leapfrog, because that was just not okay. And now we have, resources that are built on photon assay data, and is that okay? Who decides that, right? And PXRF was another very tricky one, and Michael, and you talked about him before, has got a couple of key papers out on that in OSM's monograph 30. That should be, the final word on it, but still to this day it creates that confusion about, can we use portable XRF data in our announcement for our drilling results? Of course you can, right? But you just need to be transparent about it and talk about the information that you have and whether it's going to be followed up with assay data and so on. Anyway, that's a long-winded introduction to the obvious next question. At some point, we're going to have a solution that is going to be presented based on an algorithm, and we have already included a bit of this work ourselves on the kaolinite deposit, where the variation between kaolinite and halocite is something that is not easy to determine necessarily from analytical data, and you might need to, or it's very expensive to do so, and then you might need to rely on algorithms and correction factors, and all they are correction factors, but there is that anxiety that people just intrinsically have. Ooh, the JORC police will come and kidnap my babies if I put that out. Are you sensing that, and I'm saying on your side of the ditch, because the reporting regimes in the cultures are actually significantly different in a number of places. I find that, my key example is always, if you suggest to a Canadian client to sample the entire core and not leave half core, ooh, that's not on, because remember BRIEX, right? That's just, it's a no-go area. And I'm not saying that you shouldn't be careful, but I believe we've moved on from that, and that's a key example in terms of how afraid people get of this reporting regime. And I think machine learning, if that's the word that we use to tie this all together, probably has some mountains to climb there. Are you sensing that at all with clients, a bit of anxiety, or are you preparing yourselves for that at all in that space?
Yeah, we definitely are, and the company has a number of initiatives where we are partnered with groups that help to advise. They help to basically educate and advise on these subjects, so that eventually reporting standards will be able to accommodate within reason, some of the cutting edge and innovative techniques, or things that we consider to be cutting edge and innovative now, but really, first of all, aren't, and two, will become so commonplace that they're going to be accepted regardless. If we look at at the history, if you want to talk about a resource estimation done with leapfrog and implicit modeling, I mean, it was the same with, kriging a few decades before that. And, that you were supposed to use a more like a sector-based or quadrant-style modeling on paper sections. So, I mean, the industry changes constantly and new technology is being introduced constantly. If the past is any indication, what happens is convenience, accuracy, and empirical testing trump everything. Where the danger comes, and for anyone who's on LinkedIn, and has looked at most of Vastava's posts lately, sometimes the problem isn't even the reporting standards groups, it's the securities exchanges and those who oversee what is acceptable or not acceptable. And those people aren't even geologists. And that's quite scary. So at least, we're going to be dealing with these problems on a number of fronts. It's not only needed to pass the sniff test amongst geologists and people who, may be a little bit stodgy or let's say risk averse. It also needs to be palatable for investors. And investors are not necessarily people of a technical background. And so there's a duty that we have to educate people so that they can see these things for what they are, not as magic or mystery, but as mathematical approaches that could be unpicked if necessary, and also to have a set of standards and balances so that when we do something, for your case of a resource estimation that includes imputation or a machine learning understanding of one of the numerical components, I mean, the question is it right? Well, you can check that. You can just go take a sample in that region and see if it's within tolerance. So we'll simply just see new standards come into play because it's clear that people who are working in the industry want these technologies.
Yeah. No, that's well said, and I agree completely. Change happens all the time, and we'll just have to morph along with it. And I mean, obviously, the JOR code is already changing now to accommodate for a whole bunch of new things, and whether it's talking about risk or ESG, but there will be some new guidance on some more innovative things as well. So. Now look, I can talk for hours about this stuff, but anything on your mind that I've missed? What's?
I'm sure I missed 10 of your points and questions from the intro.
Look, I never prepare, and that's probably obvious to everyone. But we start somewhere and we drift left and we drift right. But I think really covered the nuts and bolts of it, and hopefully it clarifies, because we have been talking about this actually on the channel quite a bit. And I've been meaning to talk to for a long time, and hopefully it clears a few things up. But I'm sure if people have things to say, they'll say it either on LinkedIn or on YouTube, and maybe catch up again in the future, because like you say, it keeps changing. And I really enjoy working with you guys, and hopefully when the borders are a little bit more, it's not the borders anymore, it's bloody flight companies at the moment. I saw this morning that the Qantas CEO had his house egged by unhappy travelers. So if we can get out again, find a way to catch up. But you got any travel plans, or?
Well, I hope to be at IMARC shortly, so maybe I'll see you there.
Oh, IMARC, yeah. Well, long story. I'll find you offline about that at some point. I don't know. Talking about egg, last time was a wee bit too aggressive for a lot of people. It was hard getting in the building with the protesters. But now, all good, man. I really enjoyed talking with you. And good luck at IMARC, and see you around at some point.
Thanks, René. Good talking to you.
Cheers, Shawn.